Welcome to solverfy.
So now we'll work on problem 100 from chapter 17. In this problem, we're told that tooth enamel is composed of hydroxyapatite, whose simplest formula is Ca5PO43OH, and whose corresponding KSP is equal to 6.8 times 10 to the minus 27. As discussed in the chemistry and life box on page 746, fluoride in fluorinated water or in toothpaste reacts with hydroxyapatite to form fluoroapatite, which is Ca5PO43F, whose KSP is equal to 1.0 times 10 to the minus 60. So first they ask us to write the expression for the solubility constant for hydroxyapatite and fluoroapatite. So if we look back at the page that they reference, we know that for the hydroxyapatite, the KSP will be equal to the concentration of each ion. So calcium 2 plus to the 5th power, since there's 5 calciums. Phosphate PO4 3 minus to the 3rd power, and times the concentration of a hydroxide. So this here, if we substitute x values, we have 5x for calcium to the 5th power, 3x to the 3rd power for phosphate, and x for hydroxide. And so we put 5 to the 5th power and multiply by 27, and we get 84,375. And we add up our x's. We have x to the 5th plus x to the 3rd times x to the 1st. So we have x to the 9th. So that's our expression for the KSP for hydroxyapatite. For the fluoroapatite, it's the same thing, except the last ion is changed from hydroxy to fluoride. And since all of the subscripts and superscripts, or coefficients and superscripts, are the same, we have the same value, 84,375 x to the 9th power. So in part B of this problem, we're asked to calculate the molar solubility of each of these compounds. So we simply need to set KSP to the expression we just derived and solve for x. So KSP for the hydroxyapatite is 6.8 times 10 to the minus 27, which is equal to, as we just calculated, 84,375 x to the 9th power. So we divide both sides by 84,375 and then take the 9th root of both sides, and we get x is equal to 3.51 times 10 to the minus 4 molar. For the fluoro, we get 1.0 times 10 to the minus 60 is equal to the same expression, 84,375 x to the 9th. We again divide both sides by 84,375 and take the 9th power. And we get x is equal to 6.11 times 10 to the negative 8 molar. So you can see now how adding the fluorine to this reduces the solubility of hydroxyapatite by a factor of 4.